Okay, so okay. So the first thing I wanted to show just with parametric curves, and this is really just a kind of example that you can take a look at. I'll put it on the site. You can play around with it. But all of these curves that we're going to be talking about today can be controlled through equations, or at least in these parametric curves. But I wanted to give you kind of just a brief thing about plotting curves in Grasshopper, or the same thing kind of applies in like your graphing calculator. You can do the similar things. So if we look at the a typical equation for, let's say, a parabola, which is one of the easier ones to graph, you can set some value for x and get a value for y out. It's a typical kind of function, right? F of x equals x squared is an exponential parabolic function. But you can actually rewrite that in terms of that parameter that we just talked about, t. So instead of talking about it in terms of giving it an x, you can actually kind of extract x and y. And in this case, you can rewrite a parabolic function as in terms of t. So x is equal to t, and y is equal to t squared. So what does that mean for what we're doing? So let me just start with taking a range of numbers. So I'm just going to, I've got a couple of sliders here, and I'm using this domain component, which is under maths and domain. And it's this one where we created a domain or an interval over two specific numbers. So in this case, I'm giving it -10 to 10, and I can control those, I can slide them. And it's given me that as a domain, right? So then that way I can use this range function, which really just says, okay, over a specific domain, how many numbers do you want me to find? Like, how many intervals do you want me to extract from it? So it's sort of a way to kind of divide a range of numbers up into a series of values. So in this case, I'm taking the range from -10 to 10, and I'm extracting 100 values from that range, sort of evenly spaced. So it goes, -10, -9.8, 9.6, whatever, all the way up to 10. So it's stepping in terms of 0.2 of a decimal point each time. I could easily, go down to like 20 values. In that case, it'll go from, -10, stepping in integer values up to 10. So this is really just a way to generate a quick series of numbers that I can control, and they're in a specific domain. Okay, so we've got this list of numbers here, and what I'm going to do is I'm actually just going to input these two equations here, this x is equal to t and y is equal to t squared, to basically plot that function. And the way I'm going to do it is I'm using let's see, under, where is it, maths? Oh yeah, sorry. Under maths and script, I'm just using this evaluate function, which allows us to change the x and y inputs and give it a function. So in this case, my function is t, which is, I'm basically saying x is equal to t, and in this lower one I'm saying y is equal to t squared. And the way you have to write t squared as a function is we have to use the function POW for power, raise it to a power. So I'm raising t to the power of 2. That's just what that notation is indicating. So anyway, if we look at these, so I'm just going to plug these values into a point component, and so it's graphing that function for me. So this is x squared, or sorry, y equals x squared as a function of plots. And if we wanted, we can actually get a curve through that. So I'm using under curve and spline. I'm just doing an interpolated curve, and we'll talk a little bit about the differences in all these kind of curve options today as well. But I'm using an interpolated curve to generate that. And if we hide these points, we can see it. So that's the plot of that function. Obviously, we can change anything in the function. Let's say if we make 2 times t, it gets a little bit wider. We can change that here as well. These could also be inputs into our function, so we could have some extra, so that's going to make it twice as tall. We could actually put some other value, we could call it a or alpha or something like that, in our functions. We'll do that in a later one, so we can kind of control that with the slider as well, so we can see what's happening. So in the same way, you can write a parabolic function. You can write other functions. So yeah.
Okay, at the range, you have a t. What is that?
Right here. Oh, actually, I guess I should have explained. This is not. This is really just a point component. I think a number component. So I went up to parameters, and under primitive, I grabbed this number component, which is really just a container that can hold numerical values. And the only thing I did is I just changed the name of it to call it t, so that the only reason I did that was so I only have to plug in one object here. It gets a little more used down here where you got multiple things going into it, and especially here. So it's kind of a shortcut. Yeah.
You said you can only plug in one object into range. That's why you did that?
No, it's just so I could, rather than having all of these things come out of range, I can really just kind of pinch down the definition to one little value there, and we can name it so it's a little more clear. Yeah. Yeah. Yeah, so that's what t is there. It's really just this container for a numerical value. Okay, so in the same way we wrote the function for a parabolic curve, we can do the same with a circle. Circle's a little weird written parametrically. I could probably derive this for you, but basically the equation for a circle is x squared plus y squared equals 1. And the way that kind of factors out is if you want to sort of solve it for a secondary parameter called t, it basically boils down to x is equal to the cosine of t, while y is equal to the sine of t, and it works over a range from 0 to 2 pi.